Greeting dear children. Today we are going to do the midpoint theorem. What does it mean? It states a line segment joining the midpoints of two sides of a triangle is parallel to third side and is equal to half of it. What is the meaning of this? If ABC is a triangle, P and Q are the midpoints of the respective sides AB and AC, then PQ line segment is parallel to BC and PQ is equal to half of BC. Now we will prove it. How? ABC is a triangle, P and Q are the midpoints of respective sides AB and AC, and now we have to prove this PQ is parallel to BC and is equal to half of it. So we are making one construction. What is this construction? I am doing, draw a line CD parallel to BA which meets PQ at R. Okay, so what is this? I have drawn this line segment parallel to this. Now PQ is extended outwards and this extension is meeting at R to CD. Now we have to prove this PQ is parallel to BC and we have to prove PQ is half of BC. What I will take these two triangles. Prove in triangle APQ and triangle, if I have taken APQ, then triangle CRQ, what is there in these two triangles? This AQ side is equal to CQ side. Why? Because Q is the midpoint of AC. AQ is equal to CQ because Q is midpoint of AC. Next thing is angle 1 is equal to angle 2. Why? Because they are vertically opposite angles. Angle 1 is equal to angle 2, vertically opposite angles, and angle 3 is equal to angle 4. Why? By construction these two are parallel lines. AC is transversal, so angle 3 is equal to angle 4 because they are alternate angles. So angle 3 is equal to angle 4 alternate, and why they are alternate? I just told you कि AB is parallel to CD by construction. And AC is transversal, right? So by which congruence? Just check this angle, this angle, this angle, this angle and this side, they are equal. So by ASA congruence, by ASA congruence, triangle APQ is congruent to triangle CRQ. Got it? Now, if these two triangles are congruent, it means rest of the corresponding parts are also equal. It means PQ is equal to QR, PQ is equal to RQ. Also, this side is equal to this side. AP is equal to CR. AP is equal to CR both by CPCT. I can give this as a name equation 1 and equation 2 if it is required somewhere. Now see, AP is equal to CR, right? But AP is also equal to BP. Why? Because P is the midpoint of AB. So, as AP is equal to CR, but AP is equal to BP. Why? Because P is midpoint of AB. Right. So what does it infer? AP and BP are equal, so we can say BP is equal to CR. Right. BP is parallel to CR also by construction. By construction, BP is parallel to CR, and we have proved that BP is equal to CR. Now, in this quadrilateral, BPRC, one pair of opposite side is parallel as well as equal. So, it's a parallelogram, right? Therefore, quadrilateral BCRP is a parallelogram by one pair of opposite sides is parallel and equal, right? So this is a parallelogram. If it is a parallelogram, then by definition what will be there? This side will also be parallel to this side. Therefore, this PR is parallel to BC. Now we are coming to result. If PR is parallel to BC, it means PQ is also parallel to BC, because PQ is the part of PR. So parallel we have done, right? And now this also we have proved that PQ is equal to RQ by equation 1. PR is parallel to BC, and we can say PR is also equal to BC. PR is equal to PQ plus QR is equal to BC. Why? These are the opposite sides of parallelogram, no? PQ plus QR. And now see from equation 1. By equation 1, PQ is equal to QR. So I can write it as twice of PQ. So twice of PQ is equal to BC. So you can say PQ is equal to half of BC. PQ half of BC. So it means PQ, we have proved this, PQ is parallel to BC, PQ is half of BC. So by 3 and 4, PQ is parallel to BC, PQ is equal to half of BC. This is what we wanted to prove, that a line segment joining the midpoints of two sides is parallel to third side and is equal to half of it. This is very important theorem. You have to learn its result, because this result is going to be used many times in next exercise. So keep in mind, a line segment joining the midpoints of two sides of a triangle is parallel to third side and is equal to half of it. We can prove its converse also. What is the statement? What will be the statement of its converse? Its converse is, what is the converse of midpoint theorem? It says, if we are having a triangle and a line segment which is passing through midpoint of one side, parallel to third side, also passes through midpoint of other side of the triangle. ABC is a triangle, PQ is a line segment such that P is the midpoint of AB, PQ is parallel to BC, then Q is also the midpoint of AC side. So this is the next theorem, this is the converse of this. We can also prove it in the similar manner. We can extend it and draw a line parallel which meets it at this point. We have taken it as R. So we will be taking, because this is given, this is parallel, this is parallel. These two sides are parallel by construction, and this is also given to be parallel. So here construction is same as previous. See, now for proof we will be starting from which side? We will start from this triangle, this quadrilateral BPRC. In quadrilateral BPRC, this side is parallel to this side is parallel to this. So it's a parallelogram. If it is a parallelogram, then it means this side will be equal to this side, right? And this whole side will be equal to this. Now this is sufficient for us कि this is a parallelogram and this side is parallel to this and this is equal to this. Now in this C, in these two triangles, because P is the midpoint and BP is equal to CR, it means AP is also equal to CR. So this side is equal to this is equal to this by vertically opposite angle, and this angle will be equal to this angle. So by which congruence again? So this is AAS congruence. Both the triangle will be congruent. So this side will be equal to this side, and this will be equal to this. If this is equal to this, it means this is a midpoint. This Q is the midpoint of AC side. This is the only thing which we had to prove. Converse is not that very important in the proof point of view, but results both are very important. What is the result of the converse? If in a triangle, a line segment passing through midpoint of one side parallel to another side also passes through midpoint of the third side. So these two results you have to keep in mind. Then we will start our exercise 8.2. So thank you. Complete this in your notebook and revise properly. Keep learning. Bye-bye.